Hello, folks. Welcome to Rational Science, the only site on the internet that does physics rationally, that does physics at all, for that matter. We got a great day today, so let's see if we can get directly into it. I'm going to start a little bit with our extinction segment and related questions. Okay, so here's the first one. A fellow asked the following. I'm going to try to answer him. He says, I wish Millet, he misspelled that. I wish Millet the best of the best, but it will be very hard. People there, are in Argentina, right? He's the president of Argentina. Don't know how to live without government help. Then he continues, and he says, what do you think will happen in the U.S. this year with presidential elections? Okay, first let me clarify something about Millet's last name. Someone asked about that. Millet in Spanish, Millet, if you separate those two words, stands for my law. That's direct, except that Millet, his last name is with I, whereas my law, Millet, goes with a Y. Okay, that's the only difference. But the pronunciation is the same. So Millet stands for my law, and I guess, yeah, he did it his way. Okay, just so you know. Anyways, I don't care about politics. Not into politics for many, many years now. Got out of politics. You learn a lot over time, and politics is essentially opinion. Okay, it's opinion. And therefore, opinion, what is opinion? Opinion is religion, just belief. So one person has one belief or another, or you have recommendations for how the world should be run, etc., and they go with this guy because they think that person's going to deliver what he thinks is the ideal situation or the ideal politics or whatever. And I'm way out of that completely today. I don't get involved into choosing sides or any of that. What I do is essentially say, I work at it the other way around. First of all, I only look at politics in relation to and economics in relation to extinction. Okay, that's the first thing. But then the other one is that I don't say this is what we should do, this is what is good or etc. or bad or whatever. Now I say, look, if you do this, this will be the consequence, and that's more like what is taught in political science. Political science includes a lot of subjects, including murder, I guess, of assassinations. It's not really part of political science, but, it's not a branch of political science, but it is part of politics, right? So even that's acceptable or in the political world. And you have to get used to it. Yeah, there are assassinations, and that might even happen to this gentleman, Millet. He may not make it to the end of his term. Okay, okay, and I'll withhold my opinion on that. Anyways, the point here is that I don't look at it. This is what we should do, and this is what the politicians should do. No, if they do this, this is going to be the consequence. That's the way I look at it. And every policy that you implement, depending on the country, has its results, and you have to live with those results. And a good way of looking at what results we've had is looking at the history and saying, what was done in the past and what outcomes did we get out of those policies. And that's the way you should look at politics as far as I'm concerned. Other than that, I put it in the context of extinction, and I'm saying all these people, no matter what they do, is irrelevant. All of them. I don't care what the Chinese do, what the Russians do, what every country in Africa does, every country in South America. It doesn't matter because we're all due for extinction, and it's inevitable. And none of these politicians will be able to change that course. Okay, so that's why I don't pay attention to politics anymore. Another reason. Okay, another person asked a similar question. He says, you've spoken about your falling out with socialism. A lot of people argue whether or not Marxism could work as a political system. The truth is, any political or economic system can work as long as it works on paper, right? We can make anything work for that matter. But, we're humans, and we have 8 billion minds out there, each one pulling their cart in their own direction, It's very hard to put that all together. There is nothing wrong with anarchism or democracy or a 1984 state. People can organize societies in all sorts of ways, and those systems can last for hundreds of years. Aha. The key is the content of the system, in other words, the people, right? The people can be errant, faithful, industrious, or hopeless. They make or break the system because living things, especially humans, are unpredictable. Yeah, meaning we all have our ways of thinking, and therefore, you can't say that this policy is going to produce this effect necessarily. There's a tendency to produce certain effects, but not precisely the one you want. Okay, that's the point. And this tells us that the culture, and more importantly, genetics, is the determining factor in the success of a political or economic system. I'm not going to say that genetics really has a bearing. You take the American Indians. They were displaced by the U.S. Army in the late 19th century. Killed a lot of Indians, and essentially you were fighting, you had Indians who were in the hunter-gathering stage. They were still shooting arrows at buffalo, and they were competing against people who were much better armed, right, better organized, more population also, etc. And so, the white man, he displaced the red man. That's what actually happened. And you have people like Ayn Rand, she says, well, they deserved it because they were weak. I wouldn't take it that far, but what is a reality is that, someone who is superior in development will usually conquer someone who is less developed and enslave them or, compel them to pay tribute, which is about the same thing. So this does happen. It's happened throughout history. And it's not the fault of the Indians. I wouldn't say they deserved it, but it's what happened. Okay? And there was not much they could do about it. They were displaced out of their lands, pushed out, and the white man took over. And this land is our land now. It's not your land anymore. That's the way it worked. And that's all you can say about politics. It's just the law of the strongest. Okay? In the end, that's what it is. And only when two strong or equally strong groups meet, that's when they decide to sign a treaty of some kind. Otherwise, the strong will always overcome the weak. And so, and again, I don't see this in the context of extinction. I don't think it really matters. We're due for extinction. There's nothing we can do about it. Why? Because the whole system is going to collapse. Economic system. It's going to collapse. It's going to collapse partly due to wars. We're now getting into all these wars. We can say we've started World War III in the sense that, the whole world is up in arms in many parts of the world. At least there's a lot of activity, right? And it might stop a few months down the road, or it could get worse. And if it gets worse, you can say that, now you're seeing the beginning of World War III. What is different about World War III than from World War II or World War I is that we're in the service economy. And so manufacturing is not going to put people back to work like it did, in World War II, for example. That's not going to happen. And so war is now doesn't favor getting more jobs, expanding, etc. War is now going to be destructive only. There will be nothing getting us out of war other than, treaties and having peace with our neighbor. And that's another reason for which I don't get involved into politics anymore, is that, when I was in my 20s, I knew everything about politics. You couldn't convince me of anything. I was an expert in politics, and that is, you wanted this ideal world. You wanted the brotherhood of man, love thy neighbor, peace on earth, goodwill to man. It never happened, at least in my lifetime, and I don't think it'll ever happen. It's a great ideal, but Mother Nature has other plans, and what Mother Nature has, as far as I'm concerned, is competition. You need to fight. They want people to fight. The lion doesn't reach an agreement with the other lion and say, look, let's not fight, guys. Why don't we just, share our harems with each other? You get to sleep with her and I get to sleep with the other one over there. No, it doesn't work that way. You got to fight. You're forced to fight. Mother Nature wants you to fight. And T-Rexes must have had the same situation. I would take it all the way to the Cambrian, right? There's always been competition, fighting. When that stops, it's because the animals don't exist anymore. They're not around. They disappeared. They became extinct. So the way I look at all this is very simple, and that is that, let me turn this off here for a second here. That is that, competition is how Mother Nature likes it. She wants, within the species and between species, for there to be fighting. There's got to be a struggle, and this socialism, you could say, where we're all brothers, we agree to lay down our weapons and work together, like in some of these, they call them kolkhozes in Russian, or in kibbutz in Israel, these agricultural compounds where they all get together, these cooperatives and so on. And that's not the way it works for the whole world. You can't run the world like that. And that's what I used to believe in. I don't believe in that anymore. and fought for it and so on. Won't do it anymore. I learned my lesson. Okay, Wendell says the following. This one struck a chord with me. It says, dinosaurs didn't go extinct. Oh my God, I didn't know that. Okay, it's just false to think that modern biological classification doesn't assert fairly strongly that birds are dinosaurs. It's a consensus. The way biology classifies species and groups of species is in terms of evolutionary descent. And there's just no account of what the group dinosaur is that would include, for example, T-Rex and stegosaurs, and not include eagles and crows and ravens. In other words, he says the term dinosaur has not been very precisely defined. It's kind of broadly defined, and it includes the birds. So he says dinosaurs didn't go extinct because the birds are still around. That's what not only him, but lots of people out there say this. No. No, once again, no way. So what's the problem with this? Well, we got to go kind of slowly here, okay? You look at birds, and are they dinosaurs? Well, let's find out, because this fellow says that's what the biologists, paleontologists, they all agreed, they have this consensus that birds are dinosaurs, okay? Dinosaurs, if you recall, Jurassic and Cretaceous, right? And before the Jurassic, there was a period known as the Triassic. And the kings of the Triassic were the archosaurs, okay? And so you look it up and you find out this. Archosaurs is a clade of diapsid, sauropsid, tetrapods, with birds and crocodilians being the only living representative. Birds? I thought they were dinosaurs. Now it turns out that the birds are archosaurs. They're like, those crocodiles there, because that's what archosaurs were primarily. They were these crocodiles that walked on either 2 legs or 4 legs, so they were more like land animals, I guess. But this is what these were the reigning species throughout the Triassic. And now this person says that everybody's agreed that the birds really are dinosaurs. And here it says they were not dinosaurs, they were archosaurs. Or at least that they were not, they're not saying that they were not dinosaurs, but that they're archosaurs. Archosaurs are distinct from dinosaurs. So are birds dinosaurs or are they archosaurs? And you can see there it says, the whole thing, same thing, that Archosauria includes crocodilians and extinct relatives, and includes birds. Okay, so it's confirmed birds are archosaurs, or descend from them. So what's the problem here? Can we really say that dinosaurs never went extinct because the birds are still around and they are part of the dinosaurs? Well, we can just as well say the archosaurs never went extinct because the birds are still around. In fact, I'll go even further and say that the synapsids, the mammal-like reptiles of the Permian, they never went extinct because the birds are still around. And, the amphibians of the Carboniferous, they wouldn't go extinct because the birds are still around. And I guess I can take that all the way to Cambrian. So what's the problem here? Well, the problem here is when people use things out of context, words out of context, because they never defined them in the proper context. Okay? When they talk about clades in a given context, you can say that, birds came from a similar line or branched off from the dinosaurs sometime in the past. That's different than talking about extinction. Okay, when we talk about extinction, we know what an archosaur is. And we don't say, oh, the archosaurs are still around because the birds are still flying around. No, we don't say that because the archosaur, in the context of extinction, refers to those animals that died at the end of the Triassic. There are no archosaurs today. And I don't care if birds are archosaurs or not. There are no archosaurs in the context of extinction. And when we talk about the extinction of the dinosaurs, we're talking about the same thing. We're saying that those dinosaurs that we call dinosaurs, that everybody relates to and normally associates with the word dinosaurs, those died at the end of the Cretaceous. Okay, they're not around anymore. What we have around today is a branch that branched off early, and we don't call them dinosaurs. We don't call a bird a dinosaur. Okay. And so, because if we do, then we have this situation. You got to watch out in New York City if one of these T-Rexes that are still flying around. You look at the sky, call 911 if you see something like this. No, the birds are still around because they're not dinosaurs in the context of the word extinction. In the context of the word extinction, you're talking about two different things when you say that the dinosaurs are still alive today because the birds are alive. That's an irrational statement, okay? Because you're confusing the context. That's the problem there, okay? Here, can we say that the synapsids are still around? The pelycosaurs of the Permian or the therapsids of the late Permian? Let me show you a picture here of these. Okay, these are the synapsids. So it's one of two major clades of vertebrate animals in the group Amniota. Okay, the other being the therapsids. Okay, so which includes the reptiles and birds. Okay, so the first ones, the synapsids, they include us. They include the mammals. Okay, we descend from them. We did not descend from the therapsids or the reptiles or the birds. We descended from the synapsids. Okay, so there you have two examples. The one on the left is Dimetrodon, and the one on the right is Gorgonops. Okay, first one is the one on the left is more from the early Permian. The second one is from the late Permian. Do any of those look like your mother? Okay, if they do, well, then maybe the synapsids are still around. But if your mother looks a little different than them, then maybe, the synapsids are no longer around because we descend from the synapsids as well. So it's irrational to say that the synapsids never became extinct because we humans are still alive and we descend from them. How far are you going to take this? Again, it means that you're not understanding the context when you say something dumb like that. Like saying, the birds are still around and so the dinosaurs didn't die. No, that's the wrong context, okay? The dinosaurs died at 65 million years ago. No dinosaur survived. What we call a dinosaur, and in the context of extinction, that's what we call a dinosaur. You cannot say that the dinosaurs are still living and flying around New York City because, we still have birds, which are dinosaurs. No, birds are not dinosaurs for that purposes, for the purposes of extinction. That's the context. Please do not confuse it, okay? Don't make irrational statements like saying, the dinosaurs are still around because the birds are flying. This comes out of paleontologists who are not really paleontologists. What they are is stamp collectors. You know, people think a paleontologist is a guy who goes in there like, you know, Indiana Jones. You know, he goes with a gun and with a whip. Are those the tools of a paleontologist? A gun and a whip? Oh yeah, sometimes he takes a pick and a hammer also. Where does he go? He goes in there and he, you know, breaks up the rock, pulls out a bone, assembles it, puts it in a museum, and starts collecting money. Now that's not a paleontologist. That is a stamp collector. Paleontologist is one thing and one thing only. It's a person who can explain extinction, because it's part of science, and science is only about explaining rationally. So we need a rational explanation for extinction. That's what a paleontologist does. And we don't have any paleontologists on Earth because all paleontologists have irrational explanations for how animals in the past died. They don't have an explanation for mass extinction or for background extinction, you know, when a single species dies. All background extinctions, man did them all. We killed them all. That's the answer they'll give you. It's an irrational explanation. And then a mechanism. And then how did the mass extinctions occur in the past? Well, they have no clue. They always come up with all these catastrophes. It's only catastrophes that they put forth. Oh, there was a climate change. Oh, there was a disease. Oh, there was an asteroid that hit the Earth, or maybe a supernova that blew up there somewhere in the skies. No, none of those can explain. The only thing an extinction theory, a theory of extinction has to explain, and that is selectivity. If you cannot explain selectivity, you do not have a theory of extinction, because that's the only thing you have to explain. How does Mother Nature choose a clade or an order or whatever, a group of animals, and leave the ones next to them alive? And when they have to go in, you know, and do ad hoc stuff, like, you know, for every species, you got to make an exception. Say, well, this one was hit by sulfuric acid, and the other one, it was acid rain. And no, when you have to, you know, make an exception for every species, it's because you don't have a theory. Mother Nature doesn't have 100 different theories, 100 different mechanisms for producing extinction. Okay, she only has one for mass extinction and one for background. Okay, there are no billions of theories for how animals disappear. Okay, and hopefully they're all natural. Mother Nature is natural. Okay, so here we have one extinction that happened. It's called the Olson's extinction. It happened somewhere around the mid-Permian. Okay, and I like what they say here. It says possible causes. This is out of the Wikipedia. In the peer-reviewed encyclopedia, people sometimes say, "Oh, but the Wikipedia, you know, anybody can post there." Not so. It's peer-reviewed. You try to change some of the, especially the scientific articles, and you'll find a whole bunch of people who peer-review what you just said. They won't allow you to put anything you want in there. So yeah, you can say it's peer-reviewed, especially when it's run by or monitored by a lot of so-called scientists out there that have their ideas from college, from university. They will not allow you to put just anything in the Wikipedia. So don't tell me it's not peer-reviewed. It is. Unofficially, but it is. It's censored. Okay. Anyways, Olson's mass extinction out of the Wikipedia. Possible causes. There is no widely accepted theory for the cause of Olson's extinction. No kidding. They don't have a theory for any of the extinctions, for that matter. Recent research has indicated that climate change may be a possible cause. Climate change cannot cause an extinction. Never caused an extinction on the face of the earth in the history of life on Earth. Extreme environments were observed from the Permian of Kansas, which resulted from a combination of hot climate and acidic waters. And that's all they can produce, these nonsense theories. You know, they cannot explain with this how animals die. They don't die because the climate changed over thousands of years. It doesn't work that way. Okay? And here you can see what happened. This is Olson's extinction right there around the center of the Permian, somewhere in the middle. Okay? And you can see there was a difference in the types of synapsids. You got the age of pelycosaurs, the ones on the left that look more like reptiles. You got the other ones, the therapsids, and they look more like, you know, lions, you could say, you know, or hippopotamuses or whatever. Okay, so you can see they're kind of different. But what's the issue here? The issue is that you say, well, why are these animals not, especially the cerapsids, right? Why aren't they classified as mammals? They look pretty much like mammals to me. And the reason they're not mammals is these are lions that laid eggs. These are wolves that laid eggs, or bears that laid eggs. Okay, these animals laid eggs. That's why they have some characteristics of mammals and some characteristics of reptiles. You know, I mean, we're talking about way back when. And so, yeah, we can't say that the therapsids or the synapsids or the mammal-like reptiles in general are still around because we are still alive. That's not rational. And here's another take. This is the dinosaurs group. Okay, they really started around the Triassic. There you can see some of the types of dinosaurs they found in those days. We have very few samples from the Triassic, really from the middle Triassic onwards. And then really they bloomed in the Jurassic. And you say, well, why did they bloom? Well, a good reason that they bloom is in the Triassic. At the end of the Triassic, at the border with the Jurassic, the dicrodiums, type of seed fern, died out. And it's not just one plant, it was a family or order of plants called dicrodiums. And they were all over the planet. So the point here is that if an archosaur wanted to live, wanted to survive, he had to eat that because that was pretty much the only food that was around. That was the issue. Okay, and so here we have the dicrodiums disappeared, and guess what? The archosaurs disappeared, except for the birds, right? And then we have the Jurassic. You had these long necks. Jurassic was specifically an age of the long necks, not exclusively, but it's characterized by dinosaurs who had long necks. When you get to the Cretaceous, you can see what's happening. There's a transition there, and you get another type of dinosaur, more or less like what I just showed for the synapsids of the Permian. What changed was the morphology of these animals. There are different types of animals. The first ones like to eat, from the high trees because they had long necks. Obviously, they had some. They were eating from the top of the trees, in other words. Whereas the ones that come in the Cretaceous, they eat more closer to the ground. Okay? And it's good that you read the Dinosaur Heresies of Robert Baker, and he does a good job of explaining all that stuff in quite a bit of detail. All I can tell you is that you cannot say that that the dinosaurs are still around because we still have birds. That's the wrong context for the word bird. You cannot associate the word bird and dinosaur together with the word extinction. We're talking about two different things. Okay, whether birds descended or were a line parallel to the dinosaurs that branched out at some point, irrelevant to the question at hand. The question at hand is the word dinosaur fits in the context of extinction. Those all died. No dinosaur survived past 65 or thereabouts, 65 million years ago. Okay, so you can't say that dinosaurs are still flying around New York City. But some people believe this, and that's what they repeat without understanding the context. Okay, let's get on with the ether. We had ether and we also had black holes. So I'm going to cover both of them. We had a couple questions on the ether. Let's see what these people have to say about the ether. Here it is. One fellow says the following, I think, here. It says, what an ether is composed of. It must be composed of some form of objects. So he's already talking about what it's comprised of, not what it is. That's the first thing we need to point out there. First sentence right up front, right? However, most types of objects are already associated with other theories. For example, particle with the standard model, and these objects would be completely unique. Well, not really, because the particle that quantum uses is not really a particle. It's a number, okay? And they called it a particle. It's a number with a unit. That's what quantum visualizes or understands when someone says particle. It's not a corpuscle. It's not a ball. So quantum doesn't have a particle hypothesis, meaning a particle, a corpuscle theory. Okay? It's completely a mathematical construct. Okay? These bits are the smallest scale objects, tiny bits of larger ether medium. They are not made of smaller objects. So we have these little bits, and I don't know what he's going to call them. He's going to call them bits. Okay, the shape of each bit is generally spherical. So far, it looks like he's talking about a particle. I mean, he could have fooled me. They are all the same size. Okay, they would not be deformable, wouldn't be able to change its shape. Okay, again, we're talking about a little ball that doesn't change its shape. Sounds very much like what the ether has always been. A bunch of particles, tiny little particles, little balls. That's what everybody always conceived of, the ether being. Couldn't gain or lose mass, an eternal object. Okay, position relative to other bits could change. In other words, we have distance, okay, changing between these little particles, meaning they're vibrating or moving around, right? The objects themselves couldn't change. Energy transfers would be simple, direct transfers of momentum as one bit ran into a neighboring bit. In other words, they don't deform, right? Bits couldn't absorb any momentum to change their shape during an impact. Okay, 100% of that momentum would result in a redirection of the bits involved. Not sure how to go from ether to your electromagnetic ropes, though. Maybe your electromagnetic ropes would be some additional phenomenon itself composed of these material patterns. Okay, I was going to answer the fellow, but someone beat me to it. So let's put his reply, very short, down to the point. He says, "You wrote nothing of substance, literally, in all that wall of text." And yeah, he's totally right, because what this fellow is saying, he's saying what the ether has always been. And there you see it, bunch of particles, vibrating particles, changing their distance with respect to each other. All the dots are the same size. They're undeformable. What else can I say? They're round. We always imagine them round. Nobody imagines them cubic or whatever. So we have to think of this as round little balls, right? Tiny ones. And what everybody who proposes the ether has to also identify as the black stuff that gives shape to each particle or contrast to each particle. Nobody does that. They say, oh, the ether. Yeah, but the ether, what's behind the ether? I mean, is ether the same thing as space, or is space backdrop to each particle that, giving shape to each particle of ether, right? But that's what the ether has always been. And so what is different from what we propose here? Here you see it. Okay, we have the rest of the world has always proposed a bunch of particles. Since the days of the Greeks, everybody assumes that what's out there is a bunch of particles that they can't see. Maybe we can touch them somehow, I don't know, but we can't see them. And so they say, well, there's these particles out there, okay? And so how many are there? Well, it's infinite. It extends to nowhere, or it's growing. I don't know. I don't know what infinite means, okay? There's no such thing as an infinite object in physics. What do we say? We say that all atoms in the universe are interconnected. They're bound to each other, okay? So we have that. And so that's different from what everybody else does. This is the only site on the planet that says that all atoms are physically interconnected. You have the Buddhists, you have the Hindus, they talk about connections through energy and all this other stuff. No, you cannot connect with concepts, okay? We connect with a physical object. We're saying two atoms are connected by a physical object that has the shape of a rope, or DNA-like entity. Two pair of twine threads, Okay, another fellow gives us an idea what the ether is. The ether is not a thing. Subject or material. Good. I'm glad that all these people begin by saying what it's not. They never tell you what it is. It tells you what it ain't. Okay, the ether is the 0 point. 0 point. On a grid. Translation from that grid is radiation, which defines all existence of matter or phenomena. It's a principle of rest versus disturbance, whatever that means. Okay, so there you have the 0 point. That's what it looks like. 0 point looks like nothing. So yeah, the ether looks like nothing, folks, according to this fellow. So yeah, once again, I always say that an etherist is a person who has no idea what the ether is. Okay, that's why he believes in the ether. That's why he proposes the ether. Okay, and so what can I say? All these people are off on a tangent. They're going out into left field. They don't even know what they're talking about because they never defined what the ether is. Okay, here we have follow-up on that, which is what is a black hole? And I put a video out there, and some people replied or put comments on that, so let's look at those. And it's really related to this ether, the fact that people don't define things. They don't think definitions are important. They dismiss that as semantics or word salad or word wizardry, and they say, you're raising semantic arguments. Well, science is 150% semantics. You got to give someone a theory that the person understands. In the case of physics, a mechanism, a cause. And if you cannot define your terms, or you have not defined your terms, and you use your terms inconsistently, then you have an irrational theory. Okay? So you have to define the terms, what is called semantics. You got to do semantics, and therefore we can understand you. Otherwise, we don't understand you. You think you gave your theory properly. We're going to be talking about that a little bit today. But what people hear out there is something else. Okay, because you have not defined your terms, and people understand different things from different terms unless the key words in your dissertation are properly defined. Okay, so here we have this fellow says he's a physicist. Comes over and says the following. He says, I don't know how to put it nicely. I don't need for people to put anything nicely here. You can cuss my mother for all I care, But as an ex-physicist, I feel that the video creator has not enough experience in physics or science in order to debate about epistemology. Okay, so I got a rotten egg in my face, maybe a foot, a boot in my face. Okay, so what did this great physicist, this great scientist say? First thing he says is, I do not see why the word object would need a rigorous definition. And that says it all. That says it all for me. Here you have, assuming he is a physicist, I will concede the claim. I don't know if it's true, but we'll concede it, right? If he is a physicist, he would be the typical physicist. In other words, a mathematical physicist. Nothing related to physics at all. It's just math, okay? What these people never found out that you can't do physics without an object. You need an object to do physics. If you wipe every object in the universe out of, you could make them disappear, what would be happening? What are you measuring? What are you watching? What's happening? There's nothing occurring. And so when these people say, that, why do you need to define the word object? It means they never went to kindergarten physics. And it applies not only to this fellow, but it applies to all so-called mathematical physicists. Meaning mathematicians. They do everything with magic. Why? Because they're always moving concepts around. They're moving the field, vibrating the field, or exciting the field. They're waving the wave. They're moving the mass. They're transferring the energy, or even worse, carrying the force, or transferring what? Information? What kind of physics is that? That's nonsense. That's poppycock. No, if you're going to use the word transfer, you better transfer an object. You can transfer a baby. You can transfer a rock. You can transfer, a lion if you want, but you can't transfer, energy. It's impossible to transfer energy because it's very hard to get a hold of all that energy, with your hand touching it, If you want to have one, meaning definition for object, why not create a definition which includes something reasonably well described by the Schwarzschild or Kerr solutions, meaning a black hole? Well, it's the other way around. You're the guy who's proposing the black hole. We clean our nose holes with black holes. Okay, so there's no such thing as a black hole. That's what the point here is. The point is that we define the word object. Once we define it in a way we can use it consistently, guess what? It eliminates all black holes, wormholes, dark matter, Big Bang, the whole works, and particles, so-called particles of quantum mechanics. All that gets washed down the drain because none of them qualify as objects, as things. You cannot say you're going to move a quantum particle because a quantum particle ain't a particle. Quantum particle is not a corpuscle. Quantum particle is something totally different. What they accelerate along the beam line at the accelerators, these nuclear accelerators, that ain't a particle. It's a number, usually measured in terms of energy. I know because I ran, accelerators. And all I can tell you is, yeah, we were told that we accelerated ion. In fact, they were called ion accelerators, okay? And ion implanters. And what it is, they say, look, you're accelerating an ion, you're accelerating an electron, or you're accelerating whatever. And you say, well, what is an electron? Is it a particle? No. An electron is a charge. 1.6 times 10 to the minus 19 coulombs. That's what an electron is. That's what a mathematician sees. That's what he understands. Don't tell him about little balls. He doesn't understand that stuff. He doesn't deal with that stuff. He just says that's a charge. That's so many charges that went down the beam line. That's the way they look at it. So yeah, this fellow doesn't know why we have to define the word object. No, he said, why don't you define it in such a way that you include black holes? Because we can't. You can't define it in such a way you include black holes, because then you would be using the term inconsistently. That's why you can't. In fact, here's a better one for you. You better get a beer at this point, okay? There's such a thing called an unparticle. We have the particle and we have the unparticle. Okay, here it is, the unparticle. Wikipedia, again, the peer-reviewed encyclopedia. A form of matter that cannot be explained in terms of particles because its components are scale invariant. Electrons, for example, always have the same mass regardless of their energy or momentum. But this is not always the case. Massless particles, such as photons, can exist with their properties scaled equally. Okay? This immunity to scaling is called scale invariance. So now you know what an unparticle is. We have the particles, which ain't particles, and then you have the unparticles, which I guess ain't particles either. Yeah, they come up with all this nonsense because mathematical physicists don't work with things, with objects. They never knew they had to define the word object, the word thing. And it turns out you can't do physics without a thing, meaning that the first word you have to define in physics is the word thing. What is a thing? And they never did in the last 10,000 years. This is the first site that defines the word thing. What is a thing? What is a something? An object, a body, substance. Okay, someone says, Bill, the requirements of an object-based reality aren't for everyone. Well, they had better be. Let me tell you this. They had better be for everyone, because if you don't put an object in there, in that invisible area, intangible area, between two magnets or between the earth and the sun, if you don't put an object there, then you're doing black magic. You're not even doing religion. Religion is just supernatural. Using action at a distance, that's irrational. That's not, because at least put an angel in there. You want to put an angel, you want to put God, you want to put a spirit, ghost, no problem. Put something in there and say, look, let me show you how I think action at a distance is done. And you put God in there and say, look, here's God, he moves his magic wand, this is how he does it. Okay, we can listen to that, But if the guy says, look, you have the earth and the sun, and it's all done by action at a distance, nothing in between, then you're not even doing religion. You're doing irrationality, total irrationality. And hopefully you don't put a concept in there such as a field or energy or, mass or anything like that, That's even worse. That means we have to take you to the nut house. Okay, another fellow says, black hole, an object. An object, a thing. He says a black hole is a thing. That's what he thinks it is. So heavy, it's constantly crushing itself into a smaller and smaller object, and it does this faster than light speed. This is what he was taught at the monastery. Okay? An object that is being crushed. Well, doesn't it crush itself all the way out of existence? I mean, are there still atoms there left over? Or are the atoms also crushed out of existence? What happened to the other atom? I mean, do we end up with one atom? Or do we end up with 0 atoms? Nothing, no volume. And the correct answer is this second one. It ends up with nothing. Absolutely nothing. And our good friend, what was his name? Subramanian Chandrasekhar proved that mathematically. He won the 1983 Nobel Prize for proving. Listen carefully. And people say, no, well, that's not true. for proving that a black hole collapses to zero volume, zero size, no shape, no diameter, no radius, no nothing. The definition of absolutely nothing, vacuum, and space. So, yeah, black hole is zero dimensional. And they say the singularity. Singularity is a mathematical term. That means zero volume, zero nothing. There's nothing there. So the star, crushes all the matter out of existence. All atoms are crushed out of existence. There's nothing there. And you end up with a singularity, which is nothing. It's the volume of nothing. And how much volume does nothing have? Well, it has nothing. That's how much volume it has. Put it in any unit you want. Okay, so yeah, this guy is just thinking that, it just crushes, and becomes a little ball. No, it doesn't stay at the little ball. It continues crushing until there's nothing there. No matter whatsoever. With no matter, well, then there's no mass, meaning, because that's the definition of mass, quantity of matter, or a measure of quantity of matter, meaning we have absolutely no mass. And so, yeah, black hole is the definition of absolutely nothing, not of something, which is what object is. So, so much for that, but this is what people believe. They just throw these things around. They don't even know what they're saying. Okay, give me a second here. Clean up here. Okay, another fellow says, what? A black hole is an object, another one, made of neutrons and protons. I mean, these people say whatever. They don't understand squat about anything. I mean, it's just unbelievable. People just say nonsense about ether and black hole. They never took the trouble to really find out what they're talking about. They just go on and say, well, because the scientists over there in Cambridge and Harvard, they told us all this stuff. And they just memorize and regurgitate, and they don't understand nothing. They don't understand half of what they're reading. Okay, here's another fellow who says, the hole in the center of a jawbreaker, okay, those candies, right, is a 3D form called a sphere. Okay, the wall of that jawbreaker has the same shape, right? Okay, the wall, yes, the inside of a football has ball shape also, right? The wall of the jawbreaker is an object. The whole space vacuum isn't. Okay, good. So far, so well. So far, we're in agreement. They both have volumes that can be calculated. Absolutely not. Forms have volume, shapes only have areas, both can be calculated. Yeah, the problem is that first sentence and that next to the last one. Yeah, the whole is not a 3D form, and it doesn't have volume. Okay, and so let's show that. Okay. In fact, you can see it right there at the bottom. Okay, you can see the jawbreaker. That's, now we're going to make an opening there, show the hole. Okay, so there you see the hole. And that's when you remove the jawbreaker completely, get rid of it, and that's what the hole looks like out there in space, right? Looks like nothing. Looks like very clear, like nothing. Okay, that's what it looks like. So, what is the volume there? What is the form? You have no form and no volume there. So I don't know what he's talking about the hole having form and volume. Not at all. Okay? But if you disagree, we challenge you to bring a hole, just a hole, okay? Not the jawbreaker, not the ball, football, whatever, just bring the hole to the conference and show us what the volume and what the form of that hole is. What are you going to bring? Okay, and here we have Bugs Bunny proving to us what I just said, okay? Hole has no form or shape. Hole has no volume. This becomes clear when the object that has shape is eliminated. See, the hole is a dependent, you could say object, and therefore it's not an object, because if it's dependent, it's a concept, okay? It's a relation between two things. You're treating the hole as an object. You're treating the ball as an object. You're making a relation, and you're saying, oh, the hole is in relation, has a spherical shape because it has the same shape as the inside wall of the ball. Wrong. When you do that, you're establishing a relation. We don't do that in science. The way we do it in science, we point and say hole. What are you going to point to? Hole in space, nothing. So the hole disappeared, as soon as you remove the ball, right? there is no such thing as a standalone whole. Okay? The whole was merely an architectural characteristic of that object. Now you see bugs, you know, here on Earth, he dug a hole in the ground. We all understand that, right? And if you remove the ground, that's what bugs looks like in the same exact position out there in outer space. Okay, is he in a hole there? He looks like he's not. Looks like he's an astronaut to me. So no, you should not confuse the hole with the thing that gives the inside. You know, it's just an architectural thing of the thing. In this case, the ball. That's what the hole is. It's part of really the ball. You're confusing whether the glass is half full or half empty, and you're saying the half empty part is a physical object. No, it's not. You know, the half empty has to stand alone. You know, we can take the water on the bottom half, you know, or whatever you got there, put it out into space, remove the glass real quick, and it'll have the shape for a split second. You can take a snapshot and you'll have water there. The top part, nothing there. You know, so the whole on the top of the glass, the empty part, you know, that's not an object. And again, people confuse these things. Okay, fellow says, draw an invisible, intangible, physical, electromagnetic thread. Okay, this is what the invisible thread looks like, you know, normally. You know, it's invisible, so you can't see it, neither can the blind man, you know. When it's visible, it looks more or less like that. I made it visible because the word thread is what we're trying to illustrate here. We're illustrating a thread. Blind man still can't see it, so see and touch have nothing to do with it. It has to do with whether the thread has shape. And then you have our single closed loop thread of the rope model, the one we propose, underlies all matter. It's you can say the elementary or fundamental entity that makes up everything in the universe. Okay? And here, let me draw something else. Here's an invisible ghost. Okay, that's what an invisible ghost looks like. The one that moved my curtain. That's what it looks like. I think it was my great-grandmother who came and visited me and talked to me or something like that. And there's a visible ghost. So you have an invisible ghost, and I can draw a visible ghost as well. You know, so. Is that little fellow there, little Casper, you know, is that ghost an object? Yeah, because it has shape. That's what an object is. So, yeah, a ghost is an object. Okay? Whereas, you know, energy is not, for example, you know. Okay, well, it says, refraction is the bending of light. We talked about bending light. In fact, we're going to talk a little bit about that today. As it passes through a medium, such as water or glass, gravitational lensing is caused by the what? Bending of space-time. You're going to bend time? How are you going to, what sense does it make to say that you're going to bend time? You know, how do you bend concepts? You grab them with your tweezers or with your hands? I mean, I don't know. The seconds, and you bend them? Due to the mass of the object, which affects the what? The path of light passing by. Well, the question is, are we talking about light as particles or are we talking about light as a stick? Because if light is a stick, then you can talk about bending. But if you talk about that light is made out of particles, discrete particles, then you're talking about deflecting, or I don't know, you can say that they swerved, they just changed course, okay? Because you can't bend a particle. So you can't talk about the bending of light or of a particle. If you're, what you're really trying to say is that it was deflated, it changed course, that's something else. Okay, but see, they're not careful about their language, so they say it bent the path of light. Well, the path, did we bend the highway, or did we deflect a series of photons? What did we do here? Or did we bend the wave, meaning the wave extends all the way to Andromeda uninterruptedly? And so then you can maybe say, well, if the wave is a thing and it extends all the way to Andromeda, yeah, we bent the wave. You can say that because it's an elongated, conceptually elongated object. Okay? It's not even an object, it's a bunch of vectors, but that's a separate issue. But if you treat the wave as a thing, you can say the wave bent. So you need to know if light is photons or a wave, an extended wave. It's a discrete particle. You cannot talk about bending light. So you got to determine what light is before you can use the word bent or the word path. Okay? And it says the major distinction is that in refraction, the light changes its direction at the interface between two transparent media, but otherwise travels in a straight line. Travels? How does a wave travel? I mean, here you have the beginning of the wave, here you have the ending of the wave, and does it travel like a little sailboat? You know, how does a wave travel? And where does it begin? Where does it end? You know, does it? There are more waves, more of these humps there. You know, and again, it talks about light passes by a massive object. And again, the problem here is the language. These people don't realize that language is important because otherwise we don't understand what they're saying because we don't know what they're referring to. What do you mean by light? I mean, are you talking about discrete particles or extended wave? What is an extended wave? Is that a concept or an object? We need to determine that first so that we can follow your presentation. Okay, and so here it is. You can see it here. There's your wave. Okay, beginning and end. Where does it begin? Where does it end? Does it travel like a little sailboat to Earth, one at a time? Or is that it extend, you know, from there to here? And if it extends uninterruptedly, then you can talk about bending if that's a physical object, which it ain't, you know, beginning there. But see, this is the issue. The issue is that people don't want to define these things. And what you're staring at is a bunch of vectors, magnitude and direction. That's what the blue and the red arrows are, just, vectors. So this is a mathematical concept that they're moving from Andromeda all the way down here if it's a wave. Okay? So you cannot even talk about the wave traveling because it's a concept. It's a mathematical concept. Concepts don't travel. You know, love does not travel. Intelligence doesn't travel. Grace, you know, whatever other concepts you can think of, they don't travel. Distance doesn't travel. Location doesn't travel. You know, no concept that I know of, especially static concept, they don't travel. Okay, so let's get on with diffraction because what we have here is what I just said serves as an introduction to this. And where do we go? Well, we start with these two fellows, and these are the new breeds of mathematical physicists. Word is too big for them. They're just mathematicians. They know nothing at all about physics. They cannot explain a single phenomenon which is invisible or intangible or mediated by invisible, intangible entities. Okay, that's the problem. These are the new breeds of mathematicians. One is Matt O'Dowd, and he runs one program. Derek Miller, he runs another one. Okay, and they make lots of money, I guess, right? They're sponsored by big companies. And what do these guys teach? Well, they just regurgitate the party line. So you're not going to learn anything from them other than nonsense. This is all they talk about, just pure nonsense, quantum mechanics and general relativity primarily, a little bit of string theory, right? And those are all irrational theories because they are all in the business of moving concepts. And, you know, that's why we need to determine what is physics, what is science. Is physics math? Just equations and predictions and observation and winning prizes and doing the talk circuit? Is that what physics is about? Or is physics about give me an explanation how the universe works? Okay, so that's the bottom line. And these people don't tell you ever how the universe works, meaning why it works the way it does. The how is always very confusing because people confuse the how with a why. You ask, how does the universe work? And they give you an equation. And I said, that's not what I wanted to hear. I wanted to know, you know, why, the cause, the mechanism that brings this spoon downwards. That's what I want to know. That's what I want to understand. And you'll never get an answer to that. Okay, so good luck. Okay, so here we have, give me a second here. This is where we start. One of these fellows, I think it's Derek Miller. He says in one of his videos, he says a Dutch physicist named Huygens proposed that light was a wave. Well, first of all, I want to clarify that Christiaan Huygens wasn't the one who proposed the wave for the first time. He published his book in 1690, 25 years after Robert Hooke, he wrote his Micrographia in 1665, 20 years earlier. That's where the notion that light is a wave started. Okay, as far as I know, that's as far as I could trace it. I don't know if there was anyone on Earth other than Robert Hooke that came up with that. I have to also believe that it was Robert Hooke because he's the first guy who used a microscope to study light, and he saw these wavy fringes, and that's where he thought that maybe light was some kind of wave. That's why he proposed for the first time that light is a wave. And then Huygens, many years later, sided with Robert Hooke against Newton. Newton continued to believe in the ether, in that that light was a bunch of particles. The only problem there was that whereas some of them said, yeah, we believe in the ether too, but the ether waves up and down, and Newton just believed that the ether, or whatever light was traveling straight. He said that there's no way it travels up and down in oscillating manner. It travels in a straight line. And so the question was, which one was right? And so there was a debate for many years. And it says this debate, whether light was mediated by particles as Newton proposed or by waves as Huygens suggested, was settled by Thomas Young's double slit experiment. And it turns out that Thomas Young, created this diffraction. And what was that? Well, diffraction was that, you produce fringes on the wall despite that you had two slits. You would think that light passing through two slits would produce just two slits on the wall instead of produce these series of fringes. And that was surprising because they couldn't explain it. And Young explained it saying, hey, this confirms the wave nature of light because what you have is interference there and, constructive and destructive interference. That's essentially was his answer. But what's important here is that it's Thomas Young who wrote, right? He wrote this, that Newton had done an experiment. In fact, it's his third experiment that Thomas Young did. The third one is with a human hair. He took a hair and he ran light through the hair and he produced the fringes also. So he did not need the slits. He wanted something very thin. He found a hair. He says Newton had already done that experiment somehow, and apparently Newton didn't see the fringes. I don't even know how Thomas Young did it, but he said he measured the fringes using a hair as well. Okay, so just keep in mind that that's how things progressed, and we're talking about 1802, 1803. That's when Thomas Young came up with the diffraction. So what's the issue? The issue is that that didn't resolve the debate, because in 1900 you have Max Planck. He comes up with a quantum, and 5 years later, Einstein wrote his 4 papers, Annus Mirabilis. And what happened after that was that people started thinking that maybe light was indeed a bunch of particles. So to this day we have this wave-particle duality. It's a wave packet, whatever that is. And what they mean by that really is that it has properties of both the wave and the particle. Okay? But actually it's neither wave nor particle. So that's where we draw the line. We separate ourselves here in this site from all the nonsense coming out of mathematical physics, which is based on this unimaginable entity known as the wave particle, or particle wave, or wave packet, or duality as they call it. No, we can't do physics with dualities. First you need to identify what the mediator of light is, then you can do all the physics you want. You don't do it in reverse and say, well, let me measure, let me tell you how fast and how long, and no, we don't care about any of that. Okay? In science, you first point to the object, and then you can do whatever you want with it. Then you can explain a mechanism. And you don't go in reverse and say, well, I measured something there, and I think it's, and I simulate it with particles, or I simulate it with waves. Not the way it works. Okay? Especially when neither one, because if you're going to stay with a wave, no problem. And if you're going to do particles. But don't mix them and say, well, here, this portion I'm going to explain with a wave. Okay, that's not the way it works. Okay, so here's one site that teaches physics, okay, and they define the Huygens principle so that we understand what it is. And there's a summary at the top. Every point on a wavefront is in itself the source of spherical wavelets which spread out in the forward direction at the speed of light. The sum of these spherical wavelets forms the wavefront. In other words, you have this wavefront, and each point on that wavefront becomes the source of the next wavefront. Okay, that's essentially what Huygens said. But very clearly, we see what the next sentence is. It says, this theory did not explain. Exactly. This theory did not explain why, okay, refraction occurred in the first place, or diffraction for that matter. Okay, these are not theories. They're not explanations. What it is simply a description, which people call explanations, erroneously call explanations. Okay, and here you have Huygens stated that light is a wave propagating through space like ripples in water or sound in air. Absolutely not. But that's how Huygens and everybody else to this day visualizes it, like water waves, and that's how they explain it. You have all these water wave theorists out there. Hence, light spreads out like a wave in all directions from a source. Yeah, they do. It does, and that's why you should not talk about light in general when you're doing that. You should talk about what is the mediator of light, what does it look like, and then we can tell you why it spreads out like that. Okay? The locus of points that travel some distance during a fixed time interval is called a wavefront. Thus, from a point source of light, the locus of points that light has traveled during a fixed time period is a sphere, a circle if you consider a 2D source. So what is the problem with this? The problem is that they can't see what light is. They just say from any point source, you have light going, radially in every direction. But for that, you need to identify what light is. Tell me what light is. I mean, if it's a porcupine, or better yet, what is it? The word escaped my mind. If you have a rolled up porcupine with all these pins sticking outwards, like a star, well, if light travels along each one of those points, right, those pins that are sticking out, well, then, yeah, you can't say that because light travels radially, that because of that, that light is a wave or a particle. Okay? What it is that you have some other thing there that's stretching out, extending from that porcupine, it's extending out, and light travels simultaneously through all those, radially through all those things, okay, those extended things that extend from this star. So, you got to look at what light is before you can make any determination. You cannot talk about light unless you know what light is. And all these people start talking, and some use particles, others use waves, others use both, or whenever they say, well, this phenomenon I'm going to simulate with light, with particles, this one with waves. That's not the way it works. You can't keep changing your hypothesis, your assumptions. Okay, so I go into Quora, okay, a site that answers all kinds of questions that you always ever wanted to know, okay? And these are the explanations I got from mathematical physicists and other enthusiasts on these questions. Why, mechanism, cause, right? Does light diffract at the edges of an object? They want to know why. This is not a how question, like, I'm going to describe what happens. No, we want an explanation, we want a cause, we want a mechanism. And the next question was, what exactly is diffraction and how is it caused? In this case, the how means why. I mean, they want to know cause, mechanism again, okay? And the first question we got for them is, are these questions of physics? Because if these are not questions of physics, we're wasting our time. We're saying we're trying to answer questions which don't belong to physics. Who knows what they belong to? Mathematicians say they belong to philosophy. Okay, great. Philosophy of science, philosophy of physics. Are these questions of physics? If someone asks you, why does this fall to the ground? Is that a question of physics? The cause, what caused that to happen? The mechanism, how Mother Nature does this magic trick. Is that a valid question of physics? So that's the first question you really have to answer, because nobody can answer that question. In other words, the mathematicians just shove it aside and say, well, that's not in our job description. It's not in our line of work. But then they come in and they try to answer those questions, because all these questions are being answered by so-called physicists, mathematical physicists. Why do they come in and answer these questions if they say it's not part of their job descriptions? I mean, this is where the problem is. It starts. Okay, so here are some of the answers that these people gave out there, in this for these two questions. And again, these are a bunch of business enthusiasts, people who studied at the university. It's a mixture of people, but you can see they all answer the same thing. It says, one fellow says, imagine every point on a plane wave as a source of spherical waves called Huygens source. Okay, draw these spherical waves and then draw a common tangent. This common tangent represents the new shape of the wave. Okay, so he's just illustrating, right? This common tangent, okay, on a plane wave, there are infinite Huygens sources, and these give rise to infinitely many secondary spherical waves. Thus, the new tangent would look again plane. Okay. However, once it hits a slit, here's the explanation. Drum beat, right? Only a few Huygens sources survive, the ones in between the slit, and these give rise to a new wave front, which it will now be curved. That's not an explanation. That's just telling me what I just saw. It's like, you go to watch the magician on stage, and you ask the mathematician next to you, what just happened? Oh, very easy. I'll explain it to you. I'll tell you how. And what did he say? Well, the saw moved at 10 kilometers per hour. The guy went 5 strokes, cut the lady in 2 parts. Windows, the curtains closed, curtains open, the lady came up in one piece. Yeah, that's not a why, that's not a how did it happen. That's just what happened. And that's what mathematicians call science, just, describing what they just saw. No, we want to know how the trick is done. That's where you have to use your brain, just to tell me what you saw. I don't need the mathematicians for that. Okay, so here we have another fellow, and he says, when the rays of light hit an edge, the atoms on the edges absorb and re-emit the light wave in the form of a cylindrical wavefront. So for our description, he just says it bounces, okay? Technically, this is called extinction shift effect. It states that a wave of light interacting with any interfering medium is immediately extinguished and replaced by a new wave. Again, description, he's just saying it is so. That's all he said so far. This light always bends around corners to some extent, just like sound or ocean waves. That was his explanation for the slit experiment. Why? The cause, the mechanism of how light curves around a corner. That's it. He just stated that it does. Okay, great. Here's another fellow, and he says, light diffracts at the edge of an object because he's going to give us a why, right? An explanation. The edges act as barriers that interfere with the path of light wave, causing it to bend and spread out. He hasn't told us why. He just said they do. It bends around corners. Why? Well, because it bends around corners. That's the why, that's the cause, that's the explanation. This effect is similar to the way water waves diffract when they encounter the edges of an obstacle. Now he's just using an analogy, saying water does the same thing, but he's not explaining why the water does that, neither Huygens for that matter. Or any of these people, to this day. No one can tell you why water does that, that first source to second source, why every point on a first wave front gives origin to the waves on the second front. Okay, no one tell you why that is the case. To just say it is so, we've observed it, it happens, etc., etc. Okay, it says the amount of diffraction depends on the size of the object and the wave of the light wave. We don't care about that at all. Okay, but these are the explanations that you get. Here's a couple more, okay. Paul says, this can be explained. He uses the word explained, okay. So he's going to explain something here by the Huygens-Fresnel principle. The central idea is that each point along the wavefront of a wave acts as a discrete source of spherical waves. So far, it's a description. He just says, it is so. Each of these conceptual point sources, moreover, oscillates at the frequency, amplitude, and phase of the wave at that point. Again, it is so. The coherent superposition of the waves emanating from those conceptual point sources creates the three-dimensional wave that propagates onwards, and so on. He says, now the presence of an obstacle. Okay, now he's going to say how it turns around the corner, right? The why, the cause, how Mother Nature does this trick. Such as the corner or wall eliminates some of those conceptual point sources. Okay, and the spherical wave emanating from the point source right at the corner, therefore propagates outward as a spherical wave. Yeah, we know that's a description. He's just saying it is so. But he hasn't explained a single thing. And so what is the problem? The big problem here that we have with all these people, they don't know the difference between an explanation and a description. That's what it is. They say, I've explained. No, you haven't explained. You don't know what an explanation is. That's why you haven't explained. And math doesn't explain, or as this professor, Don Sidemanek at Pennsylvania University, one of these universities there, Lock Haven, he said, science doesn't explain. Science describes, meaning mathematical physics. Okay, they don't explain, they describe. And I don't know even if Sidemanek understands the difference between them, but at least he said, look, we don't explain, we don't tell why, we can't tell you the cause, the mechanism. That's, I guess, what he's saying. And people have not understood that to this day. They think that mathematical physicists out there can explain these phenomena. They cannot. They can only describe it mathematically, which is all that mathematical physics does. The explanation coming out of the mouth of a mathematical physics is always irrational. Always irrational. Yeah, you will never understand it because they're dealing with concepts. They don't deal with objects, or like that physicist, so-called physicist, said at the beginning, why do we have to define the word object? That's the problem for the last 10,000 years. That's been the problem. Why do we have to define the word object? That's why no one defined the word object, which is the first word you need to define in physics. So that's where the problem starts. Okay, here's another one. It says, diffraction is a word that is used to, what? Describe, correct. Diffraction is just a description the way we have it today. There's no explanation. That a wave of some kind encounters some object that it cannot pass through. Right, that's all it is. So, it is so. It cannot pass for some reason. Or equivalently, it encounters an object that only allows it to pass through one or more holes or slits. Okay, so it allows it to pass. Why does it open up on the other side? Why does we have these secondary waves that are branching out and getting bigger? In the first case, the wave would generally bend around the object. Yeah, but tell me how it bends. What caused it to bend? That's what you got to explain. He says they would. He's just saying it is so. In the second, more interesting example, the wave would create a diffraction pattern because it would interfere with itself. Yeah, we understand what happens later on. We have the interference, destructive and constructive interference. I need to know why the wave turns around corners. That's the question you haven't answered. That's the one we want to answer. We want to know why, if the wave is made out of particles, in the case of water, it's molecules, right? Why these molecules go through a little slit and then immediately widen and create this second bigger front. That's what we want to understand, right? Why do they open up? Why don't they get narrower? Why don't they extinguish? No, instead they widen. Yeah, that's the issue. And the question is whether water is a good analogy for light, which is what all these people are saying when they try to explain the slit experiment. And that's a second problem. In fact, a more important problem. Okay, there's a very good answer to this in a very popular law of nature called the Heisenberg uncertainty principle. So he's going to look at the fact that we don't know the position and the motion, the momentum of a particle. That's essentially going to be his argument. What this principle says is very simple. At a given moment in time, you can either calculate with the highest precision where a particle is or where it's moving. You can never have both. Okay? Light consists of photons. I don't know where he got that, but he's assuming their photons are particles. When you narrow the slit down so much, you know with a high precision in the horizontal plane where the photon is. But now, when the light emerges from it, you can't be entirely sure which way it's moving. Okay, and so he's saying that all these are randomly going in different directions. That's why you see a band of light emerging on the screen. These are all possible directions that a photon may take after it emerges from the slit. Well, if what this fellow is true, then we shouldn't see any fringes at all. We should see a single band on the. I mean, why would the so-called photons, if they're if we don't know where they're going, we don't know what their momentum and location or position, as they call it, is at the same time, if they are moving in any random direction, if they cannot be predicted, why do they always produce the same result? The fringes, why do we see any fringes at all? We should have that whole, I mean, if it's just a hit and miss and the particles are everywhere, every time we do this experiment, the slit experiment, we should get the whole wall covered with particles. There should not be any fringes, any separation between, those lines. And so, no, this guy has not explained anything. But when all else fails, where do we go to? We go to the Chat GPT. And this is not the Chat GPT, but something similar. It's another chatbot. And this is what the chatbot told people in Quora. Okay? It says, light diffracts at the edges of an object due to the wave nature of light. Whoa, this is what the bot is telling us. So, we got to take our hats off here. When light encounters an obstacle or passes through an aperture, it bends around the edges of the obstacle or aperture, leading to a phenomenon known as diffraction. Okay, so far it's just a definition of diffraction. You can say it's just a description. This bending of light waves is what? A result of what? Interference between the waves as they propagate through the edges, leading to the spreading of light beyond the geometric shadow of the object. Yeah, the question is, why do they spread? And the bot doesn't seem to know. So much for bots, I mean, who feeds the bots? We do, right? We put the information in there. So all they did was put the party line inside the bot's head, and the bot is just regurgitating that. This phenomenon is a fundamental characteristic of wave behavior. That's it. And it's described by the principles of wave optics. Yeah, in other words, it is so. Accept it. It's the way it is. And what's the explanation? Well, they're not part of science. They're philosophy or religion or something like that. Okay, so how about our two heroes? We have Veracidum there, Derek Muller. What does he have to say about this? Does he have any different explanation for what's happening here? Let's find out. Listen carefully, okay? I'm going to do the voice, okay? And he's going to do the show. Here it is.
I have two sources of ripples, which is basically like the two slits. This pattern is created by the ripples from the two sources interacting with each other. Where they meet, up peaks with peaks and troughs with troughs, the amplitude of the wave is increased. That's what we call constructive interference. But if the peak from one wave meets up with a trough from another, then we get destructive interference, and basically there's no wave there. And this is exactly what was happening with the light.
Okay, did you get the explanation? Great explanation, right? It is so. Why the waves turn around corners, nobody knows. That nobody explains that. They just say it does, it is so. And then the waves interfere and they continue onwards with something which we don't want to listen to or hear. What we want to understand why the wave turns around the corner, and nobody can explain that, especially when they're made out of particles. Particles don't turn corners. Okay, that's the problem. Like this other fellow the other day was trying to get that through, saying, well, it's by the law of optics or something like that. Yeah, the law of optics, yeah. It just happens. That's what law means. It just is so. Okay, and here we have the other fellow, O'Dowd, and he says the following. He tries it with a single photons. He says, this works even with single photons. You shoot them and you create the fringes. And he says, we cannot explain this. We cannot explain how this happens. And yeah, because you're using photons. You're using single particles. That's why you cannot explain this. Okay? So what this really does, if you're shooting single particles and you produce these fringes, what it shows is that you're not shooting single particles. That's the conclusion. You should reject the particle hypothesis. And instead they say, we shoot these single photons that we're convinced and certified with. We know this for a fact. We've interviewed every single particle, but for some reason these particles, do not interfere because they have nothing to interfere with. They're just, individual particles being shot one at a time. They go through the slit. But see, they go through the slit and they produce, and they go in every direction, but in every direction in lines, in a specific pattern. And the question is, if this is random, like this other fellow said, we should have that whole board covered in pink or, violet particles completely. It should be smeared. And it's not. It's got these fringes. And so they haven't explained the fringes by saying that, we have to follow Heisenberg's uncertainty principle. We don't know the momentum and position of a particle. Again, it's got nothing at all to do with the explanation, whether we know it or not, the position and momentum. Okay, and so what is the big problem? The big problem, the more fundamental problem here is that these people don't understand the difference between explanation and a description. So let's go with the definitions, scientific definitions. What is a scientific definition? Is the one Bill Gates proposes, which a lot of people say, oh, Bill, you're the only one in the universe who believes in these definitions. Yeah, it doesn't matter. It doesn't matter if it's me or whoever. X could have come up with them. That's not the criteria. The criteria is objective. Can you use them consistently in a dissertation? And if you cannot, then your definition is no good. Just that simple. It just dies by itself, the fact that you cannot defend it. Okay? So that's the way we do it in science. We don't raise hands and vote for definitions and say, well, I don't like your definition. I like his definition a little more. We don't care about that. Can you use the definition consistently? Okay, that's scientifically, rationally. Okay, so here it is. Description. It's timeless. Okay, past, present, future. Future is called prediction, right? Whereas explanation only deals with the past, exclusively with the past. What's a description? A listing of properties of an object. That's all the description is for the purposes of physics. We're not talking about ordinary speech here. We use adjectives to describe objects. What's a narrative? Well, it's the same word but applied to phenomena, to verbs, in other words, to motion. A listing, usually chronological, of events that happen. And we use adverbs to qualify those. Okay? Explanation is something totally different. Explanation causes, in the case of physics, or reasons and purpose, in the case of philosophy, underlying a phenomenon. Okay? In physics, which is what we deal with here, a physical interpretation, a mechanism underlying a cause, or to interpret the manner in which a consummated event occurred. Okay? That's what a description is. That's why an explanation is different than a description. So those are the definitions we propose. You got better mousetrap? No problem. Throw it in. Show us that you can use yours consistently. And how do we do the bending of light? Well, we don't bend any light. Okay? We do it all with straight lines. In fact, all these curves, like the other day we were talking about the gravitational lensing, light bending around, celestial objects such as the sun and so on. Now, it never happened, never will. Light does not bend. Why? Because it's all made with straight lines. In the case of gravitational lensing, you have the star, which is behind the sun, and it's got all the atoms connected to the corona of the sun. And that atom in the corona of the sun relays that same light to us. So it's all done with straight lines. You have these patterns that are all done with straight lines, and you can produce curves. That's the case here. All these people have confused the curvature of light with something done with straight lines, which are the mediators of light, which are the electromagnetic ropes. Okay, and here we see that applied to the slit experiment and how diffraction really works. And here you see it illustrated. Before we start, before you turn anything on, what you have is a flashlight or whatever, or a light source. And there you can see it's dark. And it doesn't turn on until the frequency is turned on. In other words, you turn the flashlight on, what you've done is stimulated the atoms so they're pumping faster. And because they're pumping faster, they torque the rope at a faster rate, meaning the frequency is now higher and the length is shorter. Okay? And so now it comes within the visible range. And that atom from the flashlight or source, whatever, is connected to the edges of the needle. Okay, if it's connected to the edges of the needle, and those atoms now are going to send it inwards to the screen. And that's where then now you can have constructive and destructive interference, like I explained the other day. In fact, I better do this without having this there, so you can see it. Okay, what's happening is this: you have two ropes. There we go. And as soon as one is offset to the other, with respect to the other, let's do it this way. See, what you're having is they're offset. Okay, the one link of the rope is half a link behind the other, and then you have all this in between. You have different parts, because you can see that the fringes are kind of rounded off. They're not chopped off perfectly straight. And you have all these, this range of little by little, how the ropes are becoming more in line. They're, in other words, they're, what's the word? They're at the same, the links are at the same place, in other words, especially the link that's hitting the atom on the wall, okay? And you'll have that moving from atom to atom all along the wall, okay, from every atom one to the next, until one is half a link behind the other, and at that point you have destructive interference, because, well, one rope is facing up and down, the other one is facing sideways. And so at that point, one is trying to stimulate the atom, the other one is not. Okay, so you have this fight between the two waves and the two ropes, right, the two links. And therefore the atom doesn't know what to do, and so it goes below the range of below the visible range. And that's essentially our explanation for why, so we're using a wave mechanism that we've always had, except that we don't have a wave, we have a rope. That's what people have confused the wave with all these years. It was a rope all these years, a physical rope, two twined threads, and not a electromagnetic wave, which is a bunch of vectors, magnitude and direction, which is what Maxwell came up with, because again, they were all mathematicians. They never thought in terms of objects, of things. And so in all of mathematical physics, for all these invisible, intangible agents, we don't have a thing. We only have mathematical concepts serving in lieu of things. And so with that, I will see you next week. Bye-bye.